Hey guys, welcome back to the workshop. So today we're going to see what kind of trouble I can get into. I have in my possession a few of these Blake Coaxial indicators. So those of you who don't know, coaxial indicator is used in the milling machine to find the center of holes. You can also find the center of an outside diameter. It's a handy little tool to have. By design, what's supposed to happen is this is supposed to be able to turn without making that noise. And then this part right here, you put a probe on it, and as the probe pushes up against something, it actually moves the needle. The idea being that while this is rotating slowly, you adjust your X and Y axis so that this needle deflection ends up being minimized. Once it gets to the point where the needle deflection is minimized and the needle's barely moving, that's as close as you can get to dead center of that spindle being dead center over, if it's a bore, the center of that bore or whatever it is that you're measuring. You know, obviously if what you're measuring is out of round, you can only get as close as possible. I have one of these already for myself. These three right here I've picked up over the years. I have a buyer who's looking for one right now. I could have sold these probably a long time ago if I had them in good working order. So this one actually works, but it just makes a bad noise, and it's got some crusty white material indicating that maybe some moisture had gotten in here. Interestingly enough, the other two I have also show the signs of the same horrible looking white crustiness. The difference is both of these other two are completely locked up. So no matter what I try and do here, I can't get this rod to move the needle. This rod is frozen in the body, and the other one's the same way. So what I'm going to attempt to do is I'm going to attempt to disassemble, clean, and reassemble one of these. And I've never done that before. So this ought to be good. So depending on the type of failure you're dealing with your particular indicator is going to dictate the level of disassembly that you're going to have to do. I'm thinking that, the less disassembly you can get away with, the better. So for instance, this particular indicator here, this one's frozen, but I was just able to push really hard and get this to actually move. So this was actually, there was a space here at the edge of this cone that's now gone because I pushed this in. So now you can see after just playing with it, it's now moving. And the indicator, it's moving really fast, so you can't really quite see, but it is actually working correctly by the looks of it. So that's great news. It tells me that the whole clock movement here is working correctly. So what I think I'm dealing with really is just a problem with this central shaft where it goes through the two bushings is binding. So with this particular indicator, I think I can just clean that central shaft and those bushings and put it back together, and I might be back in business with this one, which is great news. The way that this indicator works is, see where this bump is right here in the casting? Right there where that bump is, there is a second shaft that actually links to the clockwork mechanism of the indicator. So there's a shaft right here with a little arm on it that sticks out and actually engages on the back of this clockwork mechanism. And that shaft rides in the casting right here, and it comes out underneath this cone, and there's a spring in there, and it's got a plunger, and the back of this cone, as it's spinning, is allowed to push up on that, and that's what actuates this. The beauty of that design is that's what allows this other part right here to rotate, to be able to rotate constantly, because it's actually an independent piece. That also means we could take this shaft out without having to worry about like a rack or something being on here. I mean, you couldn't build this like a regular indicator, like a drop indicator. This shaft would have a rack of teeth on it, and you wouldn't even be able to remove it without taking the clockwork mechanism out. This one we can. So to remove this, all we have to do is take off this part right here. And this part is held in by this pin. This pin is not tapered, but it is a press fit. So it's going to be a little tricky to get that out. Probably not too bad. I think what I'm going to do is I'm going to get myself I'm going to grab myself one of my small vices and something to pad this so that I can grip the body of this on the bench. Alright, looks like we got a couple of washers right in there, one on each side. A lot of liquid coming out here. Maybe somebody at some point tried to lubricate this. Alright, so now I'm going to take this out of my vise and just see if this will push out. If I'm not removing this plunger, which it doesn't look like I'm going to have to do, which is great. I don't think I have to worry about it. Okay. So here we go. Let me give you a look here. So this is the end of the plunger. So if you get to this point and you can do this, happy days to you, because that means that this rod and plunger assembly, that is not stuck, and the clockwork mechanism is working perfectly fine. So the only problem with this one is that this rod is not freely moving up and down or rotating freely in these bushings that are in here. I'm just going to use an old toothbrush and try and get some of this white crusty material cleaned off of here. So I guess one of the theories on these coaxial indicators is, because apparently a lot of people have run into this problem with this white crusty corrosion appears, has to do with the fact that they're using dissimilar type metals, and that this is some sort of almost like a galvanic reaction, I think is what you call it. Isn't that what you call it when two dissimilar metals corrode when they're in close proximity with each other? So it's interesting. I'm looking at the bushing down in here. When I look down inside, look down in that bushing there, I can see what looks like corrosion on that bushing. And this one doesn't look as bad. So I'm wondering, does it seem to be okay on this side? In other words, does it bind on both sides? That's not perfect, but it's not horrible. That's definitely the stiffer of the two sides, but I think they both need a little bit of attention. Alright, so I just checked with a micrometer, and this shaft is dead on 422 thousandths, which is 27/64ths. If I had a 27/64ths reamer, I would actually try and ream these bushings. I would probably just do it by hand, very lightly, with some lubricant. The fact that I don't have a 27/64ths reamer might not be such a bad thing, because maybe I'll be able to stay out of trouble. So instead, what I'm going to do is I'm just going to try and almost like burnish these. I've got one of these lint-free wipes, and what I've got is I've got a drill bit that's significantly smaller than this bore. And what I'm going to do is I'm going to wrap this wipe around this, and I'm going to very carefully guide it into the bore. But I'm going to put just put a little bit of penetrating oil on it. I don't want to get it too messy, because I'm trying to keep as much stuff from going inside the body of this thing as possible. And I'm going to go slow in case the rag falls out of position. That way I don't have to worry about all of a sudden the bare drill bit nicking the side of the bushing. turn it into the other side. That already looks a lot better. I noticed also on this shaft, which looks perfectly clean and fine, you know, it doesn't look too bad at all, but if I give it the fingernail test, there's a spot where I could feel there's actually a little line just barely perceptible right there, but with my fingernail I could feel that line. That's some sort of buildup on there. I'm going to clean this off also. Wrap some paper around here to protect the shank, put it in my drill, and I've got this cloth that I've saturated now with this anti-corrosive chemical. Alright, so I've got it working pretty well now, and I think the key ended up being saturating my rag with solvent and really cleaning these and cleaning this shaft also. And the solvent, I think, is getting rid of what I can't really see, but what apparently is left behind is a gummy oil residue. So I've got this really good and clean now, and I just put a little bit of light machine oil on these bushings, and now when I put this together, it's a very tight tolerance, but now you see with the spring installed again, this is actually returning on its own, which is how it should work. So I'm going to put just a little bit more oil on there and then reassemble. I wish I could tell you there's an easy way to get this pin back in, considering that you have to line up the two little shims and everything else. And then it's actually, when it was stuck out, it was easier. Now that it moves freely, I'm pushing it up against this metal stand I have on my bench to just keep it all the way out so I can try and tap this pin back in. It's a very tight fit, this press fit. And then you got to periodically turn it around and make sure that that shim is still in position. A little scriber tip here just to kind of make sure that that's lined up. That ought to do it. One down, two to go. All right, the second one here ended up being pretty much a repeat of the first one. It wasn't too bad. Was able to free it up using the same process. So now I've got two repaired. This is the final one. This is the one that's the worst off of the three by the looks of it, because this one, it's fully extended right now, and unlike the other ones, I can push pretty darn hard and it doesn't want to budge. So that one's really in there tight. The other thing I noticed about this one is I saw this acorn nut and this screw sitting in the box and realized that somebody had changed this pivot screw for some reason. I don't know why. Actually, it looks like it would be too small of a diameter. And this acorn nut doesn't fit this, but the acorn nut seems to fit that screw. So I think that's the original screw and acorn nut for this pivot. So I don't know why they changed that. So that's just going to be in my way anyways. Well, I'll leave that together for now because I might not even be able to fix this one at all, depending on how bad things look. Oh, the two shims were there. So now I've got to somehow get this seized shaft out of here. Well, my first thought was if I could get this to rotate a little bit, maybe it would break free and then it would want to slide out by turning it as I pulled it out or knocked it. But if I hold it and call it, that might work, and then I can grab onto the body. And I was tempted to maybe put like a large screwdriver in the slot here, which I did, but I only lightly tried to turn it. And I didn't want to put too much force on that because I don't want to spread this apart and cause a problem here for me. So now I've got this hard plastic mallet, and I'm just going to try tapping it. There we go, it's moving. Still doesn't want to turn though. There, now it's turning. Well, this spring is much larger than the other one. It seems like the free length of that spring is a lot longer. Well, that's a good sign. That looks like the movement on this thing's working too. All right, so I'm gonna take the spring out to get it out of my way. There's also a shim up top there. Oh, of course, this one's staying right up there. On the other one, it kept coming down and getting in my way. This does seem a little slower. See how it's a little bit slower coming back? Just going to try a little bit of precision lubricant right up here near the top. Real small amount. See if we can't get that to travel down into there. That's already a big improvement. All right. Now I'm going to repeat the process that I did on the first one. Well, this is going to be a little bit different. So this plunger was a little slow to return, and then I lubricated this and it seemed to get a little bit better. And then at some point while I was burnishing these bushings, something happened to this rod and it started getting stuck. It was hanging. It wasn't doing that until after I did that. So my theory of what happened is that my rag, when I was pushing all the way inside there, that it did something, knocked something out of whack. So now, I don't know if you could see this or not, see the little plunger looks different now, and the reason is because this piece is removed. I inadvertently dislodged this. This is a little end of the plunger and it's got this spring. Now, it's hard as heck to see it, but there's actually two tangs on this thing. And it looks to me like by design, the way it's supposed to work is you push down, you line up those two tabs with two slots here, and when you push it down and rotate it, that it'll lock it in. I can't just put it together, even if this wasn't jamming up right now, I can't just put this together like this, because then this will be pushing way too much on that stem. This has to be locked back in. The problem I'm having now is, even before this got stuck completely like it is now, when this was out, I couldn't get that to go back in. So now I'm kind of stuck with a predicament of more than likely I'm going to have to, yeah, I can't even get that to come up now. More than likely I'm going to have to disassemble this more completely. There's a screw in there, but I'm worried about what that screw is actually, what the purpose of that screw is. I think I'd much rather take the movement out of this thing and deal with it that way. That is so weird that that got stuck like that now. And of course you can't really see inside there to see what's happened. Alright, so to take this movement off, you have to remove this ring. So you're going to pop this ring out. Alright, it's pretty tricky to pick these things out, and I'm trying not to scratch up the crystal too much. Alright, once those two little retaining rings are out, now that crystal should pop out. There we go. I could see this lubricant that I squirted down here is all over the dial and everything now, so that was a mistake. Now there's like a clear plastic ring. It has to come out. It seems like a pretty pointless. There you go. So there's a hand with a needle. Now I can take this out. Looks like there's a little nub right there that sits in a notch. That's so that when you turn this outer ring, this will stay locked and turn with it. Now there are 4 screws that I have to remove, and then I think that whole movement will come out. I like these Weha micro finish screwdrivers. Alright, that's a good fit. I was saying that I like these screwdrivers, and one of the reasons is because there's a hex shank on here. And I have a small nut driver set that I can't put my hand on at the moment. So I won't be able to do what I was going to do, which was get a nut driver to slide right over this and give me a handle to turn that. Alright, finally found the screwdriver the right size that might give me enough. There we go, enough leverage to get these out. Now it looks like we've got 3 screws that are almost like Loctited in or sealed in, and that must be what holds the body of the indicator movement, the clock works, into the case. Yeah, it's gonna be this is gonna be good. Trying to get this green goop out of the slot on the screw. Stubborn, but I got one out. 2 to go. Alright, now the moment of truth. Got 3 screws out. Huh. It's hanging up on something. I'm wondering if it's because this is pushed in. Oh, maybe the trick is you have to rotate this as you're pulling it out. Doesn't seem to be any problem with that. Alright, so if you wanted to take this out further, if you needed to remove this rod, if yours was really stuck and you needed to take it out, clean it, and lubricate it, this pin right here has to be removed in order for this rod, because that's a blind hole on this side, so this rod has to go out in this direction, has to come out through here. In order for that to happen, this little tiny pin right here has to be removed. I'm going to venture a guess and say that that pin is retained by a screw, which is the head of this screw that I'm looking at right here. I'm willing to bet that if I loosen the head of that screw, then I would be able to pull that pin out of there and then unlatch that spring. Once you rotate this all the way around, the little lug that the spring attaches to would also unscrew, and that would enable you to take this entire rod out this way. But I am not going to do that because I don't need to. This is moving perfectly fine. So whatever was causing it to hang is more than likely, wouldn't be surprised at all if I dislodged some debris that got stuck in the rack here. Alright, so sure enough, there was some debris in the teeth, and I cleaned this thoroughly, sprayed it out, and now it's working well. There is a recoil spring right here that is very tricky. This, I think, probably was preloaded under tension, and when I disengaged it from the rack, I think it might have unspun. So what I found was that when it unspun, the very end of the recoil spring, which is very hard to see, unhooked from that gear, so I had to hook that back on. Now that I've hooked that back on, I can rotate this, and you see it actually wants to go back. So if I had to venture a guess, I would say they're probably supposed to preload this before you install it, which is going to be pretty much impossible for me to do because there's no way for me to hold this gear with a preload on it and then insert this into the housing. It's quite possible that if I were to remove this face, which I already cleaned, that behind this face there might be a tiny hole in which you would insert a pin to actually lock the mechanism when installing it. That would be my guess. The other the other can of worms here is this block right here has a slot in it. That slot is what that little pin right there is supposed to ride up and down in. That's what keeps this rack from being able to swivel. Because obviously, you know, the teeth are on one side of this rod. It's a rack, right? That's going to stay in alignment. That can't be doing this. And that's what keeps that from happening, is when that little pin is in there. When I reinstall this movement back into the case, I've got to contend with making sure that that pin goes in that slot. So I've been playing around with it right now, and it almost looks to me like you're supposed to maybe install this tilted like this and then rotate it into position so that that goes in there. Almost seems to me like with that out like that that could actually fall down where it shouldn't be. So maybe I should reinstall this spring and plunger assembly now. Yeah, because I was thinking before that I was going to have such a hard time doing this if I had no way to hold this rod from pushing in every time I tried to push down and get this to click in. Okay, so that's almost like a bayonet type fitting where you got two tabs. You line them up with those two slots. You push this down, compress the spring, and then turn this piece so that those two tabs go into the grooves. And now that is in. Oop. Yeah. Guess I didn't rotate it far enough. Alright, now I've got it in there correctly. So this plunger and this spring must be almost like a safety feature to stop this from being able to travel too far, to over travel. Or it's some kind of shock absorber, I don't know. It's what the engineers get the big bucks to do, figure out uses for stuff like that. One definite benefit of taking out the clock movement altogether is now I can really go to town cleaning this, and then I can flush it out, not have to worry about anything that I squirt in here getting into that movement. Alright, after a few minutes of burnishing, I was able to get this to move quite freely. It's even better than the last one. And I flushed all that out, so I just got to put a little oil on this when I put it back in. But for now I got to go back to problem at hand over here, which is putting this back together. So again, I'm going to load this in. This part right here, there's a cutout right there, so I'm limited to how far over I could tilt this. Alright, so that's in now. So now if I push this up, no, I don't want to do that. I want to slide this over. So see, right now it's working okay, but notice that when the plunge is all the way out, the pointer is not even on the scale. I think that's where, if we could preload this a little bit, it would be perfect, but I don't think I'm going to be able to figure out how to do that. And I just got a fingerprint on my face that I cleaned. Yeah, all right. Well, I can re-clean it after I get it mounted. All right, I got everything cleaned up, and I got the clock movement reinstalled, and got it upside down. Anyways. And it's working well. I'm not crazy about the fact that when it's at the full extended position, that needle is below the zero, but it's the best I can hope for. So reassembly of this whole face, basically you start with this outer ring that sits over that brass plate that is the body of the clockworks. Once that's in, this retaining ring goes in. This retaining ring has countersunk holes, so that's how you know which way this goes in. So get it kind of lined up, and then install the screws. I put that little like spring retaining plate on there. That's actually what holds this outer ring on, and actually puts a little bit of tension on it so that it kind of stays in place when you rotate it. It stays put. Spins easily, but not too easily. So now I can put the outer dial in. So the outer dial has a little tab on it that has to sit in a hole on this outer ring. And that won't drop in flat like that unless you have that in the proper hole. So that's how you know it's in. Now I have to reattach the needle. And I'm thinking about, do I want to try and clock this? Let me look at my other ones, see how they are, since I didn't take those movements apart in those. Alright, so this one here, you can see the sub dial is at 0, and that needle's at close to 12 o'clock. This one, the sub dial's at 0, and the needle's actually more at like 2 o'clock or a little past that. I'm just going to check the one that I have that I kept for myself. And the one that I kept for myself, the sub dial's at 0, and the large needle is just a little past 1 o'clock. So I think I'm going to go with like the 1 o'clock area. Alright, I successfully reinstalled the needle and it's clocked at about 12 o'clock. Almost perfect. So I'm happy with that. Now I just got to get this plastic ring in there, and then the plastic lens or crystal, and the 2 retaining rings. All I have to say, one unexpected benefit of having to take this all apart was being able to clean this crystal really nicely. This came up pretty good. Well, things were going great until I installed that second retaining ring, and as soon as I did that, the movement didn't work anymore. Turns out I hadn't set the needle far enough onto the shaft, so when I put the crystal in place and put the retaining rings on, that pushed the crystal down, and it was actually keeping the needle from being able to move. So I had to take it out again, and in the process of taking one of these retaining rings out, I managed to chip the plastic. So there's actually a little imperfection right here that wasn't there. Wasn't there 15 minutes ago, but oh well. So the movement's working great. Everything's great except this is not swiveling freely enough. This should be looser. It's sticking a little bit. You know, if I compare it to one of the other ones, if I push this one down, this just is loose as heck, which is how it should be. Should be a pretty easy fix. What I'm probably going to have to do is drive that pin back out and spread open that opening a little bit further. Didn't even actually need to take the pin out. All I needed to do was stick a small screwdriver blade that fits in. There's actually a hollow area right here, right there. And by getting a blade in there and just prying up gently, I was able to unseat this enough. I think that pin is such a tight press fit that it actually was holding the two sides together and squeezing that slot down. So the act of tapping that pin in kind of closed it up, and then just by wedging something in here and doing this, I was able to free that right up. So now it works as it should. Alright, pretty good. I think really why don't we give it a test and make sure everything's okay. And I can also demonstrate how one of these work in case you haven't seen one in action. Alright, so this is my little mock setup that I just going to use to test this Blake Coaxial indicator. So what I got is I got a ring here, and we're going to just pretend that this is a bore or a cylinder, and let's say we're going to do an operation on this and we want to enlarge this bore. So I'm going to use a boring head on here. But before I install the boring head and I do that operation, what I'd like to do is I'd like to center the machine spindle on this existing hole. So I know you don't hold a round part like this and this way in a vise, but I'm just doing this. We're just going to be indicating on it. We're not doing any milling on this. I got a couple of 1, 2, 3 blocks thrown in here too, just to bring this up because it's a shallow part that I happen to have. And hell, I'll even bring this out near the edge here just to make my life a little bit easier. Actually, I don't even need both 1, 2, 3 blocks. I'm just going to lightly clamp this. Like I said, we're not milling on this. This is just for the purposes of demonstrating the the use of the coaxial indicator. So now that I've got my part set, I've got to get the finger in there. So once I eyeball this being over the center of the bore, the next thing I got to do is I got to make sure that this arm is adjusted so that it's going to make full contact as it goes around. So if I turn this, I can see that it's going to touch on this side, but it's not going to touch on that side. So I'm not actually centered. Yeah, so that's roughly, there we go. So roughly the space left between the two here is the same. So now I can adjust this extension so that it sticks out far enough. Yeah, I am not liking this screw and nut that somebody stuck in here. I think I'll try and change this back to the one that was in here before, the original one that's in the box. Again, I don't know why somebody did that. The head of that screw is all chowdered up. Alright, that should work. So now, I'll lower this down into the bore. I could see that I need to go over this way a little bit more. So just eyeballing it left to right. Now that looks good. We're just going to do a sweep all the way around and make sure that finger is staying in contact. And it is. Okay, so we're ready to do our test. So you can see as I turn the spindle, okay, the whole indicator turns with it. And the whole idea behind this coaxial indicator, as opposed to just doing a sweep with like an indicol clamp or an indicator mounted in the collet, that method, you have to use a mirror to see the back when the face is on the back side. So the whole purpose of this device is to allow you to be able to actually keep this face facing you during the whole test. So to keep this from spinning, what comes with the coaxial indicator is this little rod that screws into the side here. Alright. So now, if you have a friend, they can hold on to this while it's turning. Or, if you're like me and you have no friends, just slap a stop or something handy, like this mag base up here. So now that'll hit that. And that'll keep the face from moving so that I can see it. And we're in business. So, I'm going to focus on the subdial first. So I'm going to start with my y-axis, and I'm going to move the table in one direction and see if it gets better or worse. Alright, so that got better. Still getting better. So I'm going to stop right there just for the moment. I'm going to go to my x-axis, do the same thing. Try and go in one direction, see if it gets better or worse. It's getting worse, so I'm going to come back the other way. So that seems about as good as it's getting there, so I'm going to come back to my y. So now we've got a very small deflection on the subdial, so I'm going to change my focus to the main dial. That's alright, that's getting worse. There are actually these little black pointers right here that can be set so that you can actually, when you have it going really slow, I should have this in low range. If I had it in low range, it's a lot easier to see the upper and lower limits. Now I'm back to the other axis. Now I'm getting real close now, you can see. That's looking pretty good right there. So that's pretty darn good. Now I might not be able to get that perfect because that hole might not be perfectly round. That's pretty good though. Now you might be thinking, all right, well, Steve, how does that compare to the old tried and true method of sweeping this with an indicator? All right, so let's compare. I still have the tables locked. I haven't touched the handles. All I did was take out the coaxial, and now I'm going to use my Indicall attachment. And what this is going to let me do is this is going to let me clamp right to the outside of the spindle, the nose of the spindle. Now if you don't have an Indicall clamp like this, which they make clones that are cheaper if you want to get one and don't want to pay the big money, okay, and they're pretty reasonable used. So anyways, what you can do is you can mount an indicator post that goes in a collet. So this clamps on like this. Going to use an inter-rapid indicator, so there's no question as to, there should be no question as to the accuracy of the indicator itself being used. Alright, so I've got my vertical inter-rapid indicator set up on the Indicall, and I'm sweeping on the inside. And vertical one's nice because it's easier to see the face on it. As I rotate it all around, I don't need to use a mirror. But the vertical ones are kind of pricey, so a lot of people don't invest in them. I am in contact right there, in case you're wondering. Looks like I'm at 3.5 divisions. I'm using the drawbar to turn the spindle because I don't want to touch that Indicall arm at all by accident. So actually it's a problem. I can't turn the dial to 0 it because I will affect the reading. But it's looking to me like that's barely moving. As luck would have it, because I'm running a VFD, I can actually rotate the spindle super slow. Alright, so I shifted it into low range so that I can run that motor at a little bit higher RPM, but have it move very slowly. And I'm looking at that needle, and the deflection is negligible. And just in case, just to show that it is still in contact with the, that the contact point is still in contact with the inside of the ring, I'll touch lightly on the back and you'll see some deflection, and I'll touch lightly on the front and you'll see deflection. So that's dead center on according to my inter-rapid indicator mounted in an Indicall. And one last proof of concept here is if I unlock my x-axis and I turn the hand wheel, there we go. So I would say this is a successful test of that Blake Coaxial indicator. So the little bit of deflection that I was seeing in this needle here actually was almost non-existent in the inter-rapid. Is that an issue? Not really, because the larger point is that this did its job and was able to help me locate the exact center of that bore. The slight bit of variation could easily be a little bit of roughness or debris on this area right here even. Not too concerned about it. I think it's a good usable coaxial indicator. The one thing I did not like, I had to adjust this arm, and to adjust this arm there's this screw and nut on here that we talked about early on, and on this one for some reason the original ones were in the box here. I'm going to try and change this back to the original ones because I do not like that small screw head to deal with as opposed to this Phillips head. And look at that hole that screw is going through seems, that screw is way too small in diameter compared to the original one. Oh, I see what the problem is. That screw's stripped out. That's what the deal is. Okay. And they probably just kept the original screw so that at a later date they could figure out what size it was. All right. I can't get this nut to tighten. And the problem is the nut. That is one of these stamped sheet metal nuts where it's just a very thin, I forgot how to describe it, but basically it's a thin layer of sheet metal with slots in it as opposed to an actual thread. Well, it turns out it wasn't the nut at all. It was actually this screw has damaged threads on it, and now I know why they had the screw in there that they had in there. They probably had trouble finding this screw because this is a 632 screw, but it's got to be like 3/8 short little sucker. So originally I was going to put that cap screw in there, but it's too long. If I had a regular nut on there I could use it, but I wanted to use the original nut. So now we're all set. So that's going to complete this repair video. Hopefully you guys that are working on a Blake Coaxial found this informative and helpful. If you did, please hit the like button. And if you're not already a subscriber, please consider subscribing. Take care.